Level 0. A man collapsed on a sidewalk in Phoenix last summer. Paramedics reached him in under 8 minutes. He was already dead. The temperature that afternoon was 107.6 degrees Fahrenheit. Nobody around him treated it as an emergency. It was just a hot day. That gap between what heat actually does and what we assume it does is what this video is about. Meteorologists track heat events using the heat index, a formula combining air temperature with humidity to calculate what conditions actually feel like against skin. At 86 degrees Fahrenheit with low humidity, the body handles it. That same 86 degrees Fahrenheit at 80% humidity pushes the felt temperature past 100.4 degrees Fahrenheit. The thermometer reads identically. What your body experiences is a completely different situation. A dry desert afternoon at 104 degrees Fahrenheit can be safer than a muggy coastal city sitting at 89.6 degrees Fahrenheit. The number on your weather app is not the full picture. Sometimes it's barely even relevant. Heat at this level is background noise. Sleep gets worse. Focus drifts. Research on exam scores in schools without air conditioning consistently shows lower performance on hot days, not about effort, but because a brain already spending energy on temperature regulation has less left for everything else. Outdoor workers cramp up. People get irritable without knowing why. Productivity losses from moderate heat have been measured across industries from manufacturing to agriculture to software. And the pattern is consistent. Output drops before anyone admits they're struggling. The body is managing, technically, but managing at a cost it doesn't invoice until later. None of it feels urgent. A cold drink handles most of it. But that's exactly what makes level 0 deceptive. The body is already burning extra resources just to stay functional. The margin before something goes wrong is smaller than it looks, and the scale we're about to go through makes that margin feel very thin indeed. There's a point not far from here where the body stops compensating and starts losing. It doesn't announce itself. That's the next level. Level 1. Core temperature, 98.6 degrees Fahrenheit. The body treats that number like something worth almost any cost to defend. Blood vessels dilate near the skin to push heat outward. Sweat glands fire across nearly every square centimeter of surface area. Someone doing moderate physical work in serious heat loses more than 1 liter of fluid per hour, and that fluid isn't just water. It's sodium, potassium, magnesium, the electrolytes your heart literally runs on. Above 95 degrees Fahrenheit with real humidity, evaporation starts falling behind. The air is already saturated, sweat sits on skin longer before doing anything useful. Core temperature begins drifting upward, not dramatically, just drifting. Heat exhaustion doesn't arrive with fanfare, fatigue, headache, nausea, cramping, the kind of symptoms you'd push through on a busy afternoon, and most people do. And that's precisely why people die from this. The warning signals are ordinary enough to dismiss. That's the trap. Who gets hit hardest isn't random. Agricultural workers, construction crews, delivery riders, they don't get to decide when it's too hot to stop. Stopping means no pay. Heat exhaustion in an office worker is an afternoon off. In a field laborer, it's a data point in a report nobody reads. The exposure isn't distributed by biology, it's distributed by economics. Research consistently finds that heat-related illness and death are concentrated not in the most extreme climates, but in the most economically precarious populations within those climates. The physiological vulnerability is roughly equal. The ability to remove yourself from danger is not. Caught early, rest and fluids bring full recovery. But the window is genuinely short. Core temperature above 101.3 degrees Fahrenheit. For more than an hour starts doing things that shade and water cannot fix. The body has been patient up to this point. Past here, it stops being patient. At 104 degrees Fahrenheit core temperature, the medical category changes. And so does everything that follows from it. Level 2. Most people don't know this about heat stroke. It isn't severe heat exhaustion. It's a categorically different event. When core temperature crosses 104 degrees Fahrenheit, thermoregulation doesn't push harder, it shuts off. Sweating stops entirely. The only active internal cooling mechanism goes offline, and heat accumulates with nothing left to oppose it. The brain goes first. Confusion arrives before pain. Someone with heat stroke often has no idea anything is wrong. Speech slurs. They become erratic, strange, sometimes aggressive. Bystanders assume intoxication. The cognitive failure happens before the physical collapse, and by the time someone goes down, core temperature may already be at 105.8 or 107.6 degrees Fahrenheit. At those temperatures, proteins inside cells denature, physically unravel. The molecules responsible for every chemical reaction keeping you alive start failing at a structural level. Kidneys go first, then liver tissue, then neurons take damage that doesn't reverse when temperature eventually comes down. The organ failure isn't from dehydration. Heat is dismantling cellular architecture directly, and no amount of fluids after the fact addresses that. Heat stroke kills tens of thousands every year, probably more. Heat deaths get recorded as the cardiac arrest they triggered, not the temperature that caused it. Studies on excess mortality during heat waves find real death tolls 2 to 5 times higher than official figures. The heat disappears from the paperwork consistently, everywhere. It's a form of institutional blindness that makes the threat harder to measure and, by extension, harder to take seriously. A disease that kills this many people would trigger emergency protocols, funding surges, and international coordination. Heat, because it doesn't carry a pathogen and doesn't photograph well, gets a weather advisory and a reminder to stay hydrated. Some survivors never return to baseline. Months of neurological symptoms, chronic kidney damage, a permanently lower threshold for the next hot summer. Scale that across millions of people. 2 weeks, no cool nights. That's where this goes next. Level 3, August 2003, a heat wave parked over Europe and stayed. 2 weeks, 70,000 people died. No war, no virus, no natural disaster in any conventional sense. Heat, peacetime. The wealthiest continent on Earth. France alone, 15,000 excess deaths. Excess means above expected baseline. Those people would have been alive in a normal August. They weren't alive in this one. Paris crossed 104 degrees Fahrenheit on multiple consecutive days, but the nights were the real problem. Temperatures stayed above 77 degrees Fahrenheit after dark. Climatologists call these tropical nights. The body repays heat debt during sleep. Cool nights partially undo what hot days do. Remove that recovery window, run 77 degrees Fahrenheit evenings back to back for a week, and the physiological debt compounds with nowhere to drain. Day 4 starts worse than day 1. Day 10 is a completely different medical situation than day 1, and most people have no idea that nighttime temperature is doing more damage than the afternoon peak. Paris amplified everything. Dense stone and asphalt running 37.4 to 41 degrees Fahrenheit, warmer than surrounding countryside. Elderly residents in old top-floor apartments, no ventilation, no air conditioning, no way to leave. Hospitals understaffed because it was August and half the country was on vacation. By the time a national emergency was declared, most of the dying was already done. The institutional response wasn't slow because no one cared. It was slow because nothing in the system had been built to recognize this as the kind of emergency it was. Infrastructure failed alongside people. Power grids buckled. Rail lines warped. Road surfaces softened. Emergency services absorbed a citywide surge on capacity built for normal days. The failure wasn't confined to human biology. It was a systems failure, and the systems had been designed with no expectation that this was a thing that could happen. Climate models now put a heat wave of this exact scale as a plausible recurring European summer within 30 years. Just above this level, preparation stops being the answer. Level 4, healthy adults, full shade, unlimited water, sitting completely still. Above a specific combination of heat and humidity, they will die within hours regardless. Fitness doesn't change it. Preparation doesn't delay it meaningfully. Not a medical vulnerability, a physics boundary. Wet bulb, 35 degrees Celsius. Wet bulb temperature measures the lowest temperature achievable through evaporation, what you get by wrapping a thermometer in wet cloth and exposing it to airflow. At wet bulb 35 degrees Celsius, air is so saturated that sweat cannot evaporate. The body's primary cooling mechanism becomes physically impossible. Core temperature rises and nothing stops it. A dry city at 114.8 degrees Fahrenheit might produce wet bulb conditions around 82.4 degrees Fahrenheit. Survivable. A humid coastal city at 95 degrees Fahrenheit can hit wet bulb 35 degrees Celsius. The raw thermometer number tells you almost nothing about which is more dangerous. This is the part of the conversation that almost never makes the news, and it's arguably the most important part. Scientists assumed this was theoretical, decades away. Then researchers went back through historical weather station records and found wet bulb 35 degrees Celsius had already been reached and briefly exceeded multiple times since 2005. Persian Gulf, Pakistan, India, events lasting an hour or two, too short for mass casualties. But the conditions existed. They happened quietly, with no headlines, no emergency declarations, no international coverage, just data points logged at weather stations, sitting in archives until someone went looking. The fact that these events passed without catastrophic death tolls isn't evidence that the threshold is less dangerous than described. It's evidence that the events were brief, and that brief is the only reason the outcomes were recoverable. Duration is the variable that changes everything at this level. 6 to 8 hours at wet bulb 35 degrees Celsius, a standard workday would be unsurvivable for any outdoor worker without mechanical cooling. That duration hasn't appeared in the record yet. Hold those conditions across entire regions for entire seasons, and something beyond individual survival starts breaking. Level 5. June 29th, 2021. Lytton, British Columbia. 121.28 degrees Fahrenheit. Canada, hotter than anything ever recorded in Spain, Italy, or Greece. The following afternoon, a wildfire reached Lytton and destroyed 90% of the town in 15 minutes. Extreme sustained heat degrades land in compounding ways. Prolonged heat pulls moisture from upper soil layers until the ground turns hydrophobic, physically repelling water instead of absorbing it. Rain runs off as flash flooding instead of recharging groundwater. The soil stops functioning as soil. That distinction matters enormously because virtually all food production on Earth depends on ground that can actually absorb water. Trees drop leaves early to cut water loss. Grasses die, root systems contract. The vegetative cover that binds soil, intercepts rainfall, and moderates ground temperature disappears across massive areas. Bare Earth absorbs more solar radiation, gets hotter, stresses more vegetation, and nothing breaks that loop from the outside. The landscape doesn't degrade gradually, it shifts into a different regime, and that regime is self-reinforcing. Then fire. The 2019 to 2020 Australian bushfires burned 45.97 million acres, roughly the size of England and Wales combined. Scientists documented pyroconvective events that season, fires hot enough to generate their own internal weather systems, producing their own lightning, igniting new fires miles ahead of the front. Fires creating the conditions to spread themselves. The scale was large enough to measurably alter stratospheric chemistry across the southern hemisphere. Smoke circled the globe. 3 billion animals died. For months afterward, air quality across eastern Australia registered at levels typically associated with industrial disaster zones, not open country. Land damaged by one extreme heat season is measurably more vulnerable to the next. The degradation doesn't reset between years. Everything here is recent history. What models project for the coming decades isn't a worse version of this. It operates at a different scale entirely. Level 6. For almost all of human history, civilization has existed inside a surprisingly narrow temperature range. Not by choice, but because it's the only range where everything civilization depends on actually works. Crops grow, infrastructure holds, bodies sustain themselves across generations without chronic heat, stress breaking down the population doing the work. A 2020 study in the Proceedings of the National Academy of Sciences formalized this as the human climate niche, a mean annual temperature band of roughly 51.8 to 59 degrees Fahrenheit. Agriculture, dense population centers, the entire material infrastructure of civilization concentrated inside that band across recorded history. Every empire, every agricultural revolution, every city that ever lasted more than a few generations, built inside that range. Under high emissions scenarios, projections suggest that by 2070, between 1 and 3 billion people could be living permanently outside that range, not displaced by a single event. Structurally, climatically beyond the conditions where human civilization has ever demonstrated sustained function. There is no historical precedent to consult, no case study of a society that successfully adapted to conditions permanently outside the niche. The models point into genuinely unmapped territory. Nobody declares a region uninhabitable on a Tuesday. Crop failures stack across seasons. Aquifers stop recharging. Power grids fail on hot days, then more often, then regularly. Healthcare systems absorb not one seasonal crisis, but an unbroken sequence of them with no recovery window between. People leave, and when enough people leave, the services that remain start leaving too. Schools close, hospitals close. The grid becomes unreliable just as it becomes the only thing keeping people alive. Each departure makes the next one more likely, and no outside intervention reliably reverses a spiral once it starts moving at that scale. South Asia, Sub-Saharan Africa, the Middle East, parts of Central America, most of the world's population, agricultural systems sustaining billions already operating in temperature ranges being exceeded season by season right now. The geological record holds a heat event that makes all of this look like a preliminary signal. Level 7. 56 million years ago, a large pulse of carbon entered the atmosphere. Volcanic activity destabilized seafloor methane deposits, probably both. Global average temperatures rose by 41 to 46.4 degrees Fahrenheit across roughly 20,000 years. Paleoclimatologists named it the Paleocene-Eocene Thermal Maximum, the PETM, and it's studied as the closest natural analog in the geological record to what industrial emissions are currently doing, just at a much slower rate. Deep ocean temperatures rose, acidification intensified, Organisms forming the base of deep-sea food webs went through serious extinction events. Tropical forests pushed toward the poles. Subtropical vegetation grew at latitudes that are temperate grassland today. Species distributions shifted across entire continents over the course of millennia, but that is still fast by geological standards, and many lineages failed to keep pace. The fossil record from this period shows not just species loss, but ecosystem restructuring at a fundamental level. Communities of organisms that had coexisted for millions of years dissolving and reassembling into arrangements that had never previously existed. Mammals shrank across multiple lineages measurably over generations. Heat stress and declining nutritional density drove animals towards smaller body sizes, what researchers call Bergmann's rule inversion. It's already being measured in living species right now, responding to contemporary warming. Not a model, not a projection. Something you can observe in animals alive today. The PETM didn't end complex life. The biosphere reorganized and survived, but it unfolded over 20,000 years. Current emissions are compressing a comparable atmospheric change into roughly 200 years, 100 times faster. Whether the same survival outcome applies isn't something the PETM can fully answer. The physics is the same, the timescale is not, and timescale is what determines whether living systems have room to adapt or simply get overtaken. Carbon cycle recovery after the PETM, 200,000 years. The PETM reorganized life on Earth. The record also contains the event that came close to ending it. Level 8, 252 million years ago. 96% of all marine species gone. 70% of terrestrial vertebrates erased. The Permian-Triassic extinction, the largest in the history of complex life on this planet by a significant margin. Geologists named it the Great Dying because nothing else comes close enough to need a more specific name. Volcanic eruptions across the Siberian Traps, a province roughly the size of modern Europe, released CO2 and sulfur dioxide into the atmosphere continuously for hundreds of thousands of years. Temperatures climbed. Warming ocean floors destabilized methane hydrate deposits, releasing more greenhouse gas, pushing temperatures further. No natural counterbalancing mechanism, sustained, compounding, global. The mechanisms are not unfamiliar. They are the same mechanisms active today, operating on a geological timescale rather than a human one. Tropical ocean surface temperatures at peak extinction, estimated at 104 degrees Fahrenheit. Photosynthesis in surface waters breaks down at those temperatures. Marine phytoplankton, producing roughly half of Earth's atmospheric oxygen, stopped functioning across enormous tropical ocean areas. Dead zones spread across entire ocean basins. The equatorial marine environment became incompatible with most complex life. On land, equatorial biodiversity disappears from the fossil record during peak warming. A dead band around the tropics. Large land animals had no viable habitat there. Survival correlated with latitude. Whatever was far enough from the equator when conditions peaked had a chance. Everything else didn't. The survivors weren't better adapted in any meaningful biological sense. They were simply somewhere else when the worst of it happened. Survival is geography rather than fitness. That's a different kind of filter than the ones evolution is built around. And it left the post-Permian world impoverished in ways that took tens of millions of years to partially repair. Recovery, 10 million years. Entire lineages never returned. What we know about the Great Dying we know from rock, from absence, from the layer where certain fossils simply stop appearing and never resume. That's the whole record. A line in stone where something that had existed for hundreds of millions of years ran out of planet to live on.